Hello everybody. So today we will work a bit on my Rust project. That includes lots of particles. I wonder if I should start with a little bit of walkthrough through everything I have here and then proceed with whatever I was looking at anyway. So bit of microphone adjustment. I'm not sure how loud I am, but should be fine. Minor stream adjustments because this is my first stream. So this is my first Rust project. I started working on it a week ago, 2 weeks ago. Actually, we can check my GitHub. 2 weeks or something ago, but I took a break. So basically, this is a translation of a porting basically of my previous Rust project with lots of particles that I did to learn OpenGL. For the first one I used C++, and for this one I used Rust and OpenGL. So the OpenGL shaders are the same. Basically I didn't really touch them, but I would like to do some extra stuff for this project here. So let's look a bit at what we have here and move from that. So why am I doing this in Rust? First of all, because it's an amazing language and it's basically the first language that I see that really tried to solve the problem of safety and try to diminish memory issues and so on, but without garbage collection. So that without garbage collection, it's a huge plus for me because I really wanted to have something fast, and Rust is basically a system programming language aimed at targeting that sector while it maintains safety and a lot of other nice advantages that we'll see. I'm also a newbie in Rust, so this is my project to learn this language. So anyway, if I make mistakes, I might have to Google around and be prepared for that. Let's go through what I have here one by one, and you can see it later. So wait, where am I? Main. Okay, I was just giving a run through my project. So since this is something I worked on and we're not starting from zero, I'm gonna explain a bit what we have now. So let me show you first how it runs. Oh, by the way, this is Visual Studio Code. It's amazing for Rust. Bit slower because so hopefully the video is not super bad. I've tried to make it, it's really hard for encoders to work with this type of thing, and it either gets pixelated, either it gets, we have weird colors, but we have here about 16 million particles maybe. Anyway, there are a lot of them. And because I like particles, and I'll show you how it works, and then we'll add some new features because I want to have collisions and a bit fancier things. Oh, it's only 6 million now. So basically we have a few files. Let's go through them. The most important one is main. So here in Rust I use SDL. Let's go to the program entry. SDL is used for window management, and it's basically a wrapper over SDL2 for Rust. So it's nothing fancy, you just create your context, you get the window handle, initialize OpenGL, and then I use GLRS, I think it's called, for OpenGL bindings with Rust. So we get the OpenGL context here. This loads all the functions. We set up some debug callbacks, and then we start the main event loop here. Look at this. This is really nice in Rust. I like this. You can have break with a what's it called? Label break, and you can jump outside of, even if it's this a for loop, you can actually jump outside of this one. So actually here you don't break from this for loop. This means you break from this for loop or while loop. Anyway, it's really cool. So this main loop pulls events from SDL. If we press escape, or if we receive the quit message, we exit the program. Otherwise, we get some mouse motion for moving around. Sorry. And then we handle input, we update the particle system, we render the particle system, and we swap the buffers on our window. So this is quite the basic idea. The main action happens here in particle system. So this class is composed of a few things. We have two arrays of positions and velocities for our particles. So basically two buffers, two shader programs, one for drawing them. So this is just OpenGL programs, one for the compute shader. So their movement, the particle movement, is done using compute shaders. Some buffer objects, these are used for DirectX. For OpenGL, they're basically OpenGL handles and a bit other data you'll see. The frame buffer. So basically everything is rendered to a frame buffer, and then that frame buffer is placed on the screen. So there's two steps to render. We render to a texture, then we render that texture to our window in the second step. This way we can apply post effects, because we have that frame buffer that we can use as input for post effects and other things. And oh, this is actually the screen program. I should rename this. This is the shader program to split that frame buffer to screen, and another vertex buffer for that quad, because we need a quad in order to render full screen. So everything is initialized here with random positions. We initialize the graphic resources. I don't know how much detail I should put into these. basically okay, this is the full screen. This is the quad that's drawn at the end. Actually, yeah, this is the squad that's drawn at the end, and then we have the velocity buffer, vertex shader, fragment shader, geometry shader. This is quite interesting because let me run it again. So here I pause it with space. Oh man, I should make it move faster. You can see that they are quads, but we never describe them as quads. So actually they become quads in the geometry shader. So the geometry shader for each particle position spawns these 4 vertices and links them properly together, and then everything is drawn on the screen. So it's basically the way it goes is vertex shader, geometry shader, pixel shader, and the pixel shader rise to a frame buffer, which is a texture, and then that texture is then put on the screen here on a window. Anyway, pretty cool stuff. Not too complicated. It's a bit complicated. I really wanted to do this on the stream, but I wasn't comfortable with Rust enough to do it live from scratch. So this was a bit of an exercise in starting to get comfortable with this language, and then now I can show you a bit more. Without having to search on Stack Overflow or whatever documentation for every little render language command or whatever. Yeah, so as I said, there's these shader programs are basically a wrapper over the GL objects. As you can see here, we have vertex shader, fragment shader, geometry, and compute. And I did this so the GLRS bindings are unsafe. So these are the actual bindings. So each time you call one of those functions, it goes into, you have to put it into these unsafe blocks. And this is the way of telling us that, hey, code around here is unsafe and you should disable some of your checks because it's unsafe. And it's impossible for it to be safe, and sometimes it's actually needed because you might want to alias some buffers or whatever it's called. Anyway, my camera is moving. Anyway. So in order to avoid this ugliness of having unsafe everywhere, I wrapped all the functions I needed in this shader structure that basically has a source file, a GL handle, and a type. And basically we do here behind the scenes all we need. We load the shader. Oh, thank you for the follow, whoever followed me, I don't know. Lord Baldu. It was quite loud. Oh, but you didn't hear it, so it's cool. Okay, so as I was saying, this is just a wrapper around OpenGL functions where we link shaders, build shaders, and so on. So one of the things I really wanted to do is to try and do, maybe I started it last night because I did a tiny test stream. I need to really remember these things a bit better. Oh yeah, I did. So I wanted to put here gamma correction and tone mapping. So the thing was, because you can't really tell, for example, well, I'm not sure if on the stream you can tell at all, but theoretically this is gamma corrected according to the code I wrote in the shader here. But if I just remove this gamma corrected, oh, it's actually not gamma corrected. But if I do use gamma correction now, it should look a little bit better. As you can see, Rust has a bit of an issue with compile times, and I'm not sure if it's, well, I do have a not so fancy PC, but still. Okay. And now it's gamma corrected, but there's no way to actually tell the difference. And right now I don't support shader reloading, so I think that will be our first change for today. Oh, before I go there, let me take you. Actually, if you guys have questions, just you can ask and I can go there and try to re-explain something. So there's two main steps in our particle system: update, which is done in compute shaders, and rendering the particles. Updating means we just set the compute shader. As you can see, this is a bit not so nice because I still have some offstate stuff here. But we bind two buffers, the position and velocity buffer. We dispatch the compute work, which basically just means we start the work on that compute shader. We have a memory barrier here, which I'm not sure is needed. And then we unbind these two buffers and stop using the compute shader. So when we dispatch this, we have already the position and velocity vertex buffer objects here. This means that, let's go between the compute. Here. Let's take this compute shader is basically a shader program that runs on those two those buffers and gives all the movement to our particles. So when they touch the ground, they get respawned at a random position, and then we adjust their position a little bit. We give them some random velocities, and then if they didn't die, we just update their position with the velocity. It's basically a simple thing. We have a bit of collisions with some spheres, but now they're disabled because I'm working on something else. And this is done for each particle because we basically process a position and a velocity each time. And the beauty of it is that we write back to the buffers that were used as input. So the input position and input velocity are then updated with the new position and new velocity. So after this compute shader finishes its job, we go back here to the particle system and we render the particles. And when we render these particles, no, it's actually here. We render, we clear the frame buffer and we call render particles. When we render, we call that, we set the matrix properties for our shader and use basically the buffers, which are the position buffer and the velocity buffer from before. So the compute shader moves them, updates a buffer, and then we use that buffer to get the position buffer to draw the quads at the proper place on the world. We have here why they are quads. They're quads because for each point I emit 4 vertices here. So for each point that we draw, we create that tiny rectangles. And it's nice like this because they're already in camera space, so they're already, they will all be oriented towards the camera, so you don't have to rotate them to follow the camera like that. Since they're emitted in the right space after projection happened. Anyway, so coming back here, we render the particles and then we just draw the quad on the screen. So the quad, we render them in a texture and then we draw all that texture on the front buffer. So, and this is the end result. And currently they only have gravity. I'm super sorry that they are not so nice on the stream. I tried my best to use the best possible settings for compression, but because this is a case that actually really annoys video compression algorithms with this kind of movement, they kind of look shitty on stream, but yeah, I hope you get the idea. That they move, they fall, and this is just basically this box of particles that falls now. Huge amount of particles, and the FPS, even though on the stream it might not be great, it works super okay on my PC. So okay, we have this weird snow thing now, and we said I want to implement shader. I want to reload the shader so I don't need to change them and start the programming again. There's no need for that. So we need to do here 1 second. Okay. Thing is, I was in a vacation and I kind of forgot what I was doing here. So let's go a bit in particle system. Shaders. I think the shader itself contains all the time the address at which we load it from. Sorry, not the address, the file, the source file, yeah. Okay, so where is this set? Okay, so compile, that's the job, and then attach shader. Expects this guy to be compiled properly. Whoa. Okay, this is the GL function, it's the unsafe one. Okay. It's not ideal. We can do a dirty little trick now, I think, and then we can... Yeah, because I create this. So I create the vertex shader, I compile it, I attach it here, and I don't ever remember it. So let's just move these guys. Screen program, yeah, this was... we need to have a mutable here. It's not ideal, and I'll tell you right away, because actually we don't need to redo all of them, but it's fine for now. This should be fine. And when we press some keys, we'll reload the shaders. Let's see here. This kinda just moves the camera. Can capture it here. Wonder if this matches everything or... So... Yeah, you see, so I'm not really good at Rust in general. Oh, but it's keyed down. I wanted it to be... board states. What do we check here? This. Control R should be fine. Oh my god. Also, yeah, let's see now. I think it's like this. If not, I actually will look at the continue. Value moved. Okay, consumes it. Okay. It's not too great now, but okay. I know what happened. So because this is a really stupid way to fix this, but we'll properly do it later. Actually, it's not, because we can't reuse that ID anyway. Okay, so now I need to wonder if I can just spawn this in the right place. Which was the one that it complained? Oh, compute shader, of course. We create a new compute shader and everything should be fine. So as you can see here, we load the shaders again. and again and again. So, oh, what? I went to yeah, so it works. Cool. So now if I leave the window here and we go in the copy texture to quad, not sure, should we do it here? I think I'll move the move this this gamma correction on this other shader. Oh, look, without gamma correction. So now we can actually see the difference because we don't have to recompile everything and forget how the thing looked before we. So we need copy texture to quad. Yeah, so this will be basically post-processing will be here. So is vector 4 maybe. I'm not sure if I have alpha on that or not. It shouldn't have, but I see here that okay, and then two point two. Actually, okay, let's leave it like this and then it's correct to do here. Oh, and now it did the background as well as the let's add some random exposure. So now, oh, this is super overexposed now, and it's saturated to white actually. Let's leave it like this. And in order for so now it's not between 0 and 1, it's not between the normal color range, so we need to tone map it. So tone mapping means we get a high what's it called? A color which has a value bigger than 0.1, and we put it back into the range so it can be displayed. So one simple way to do this is to just get color and divide it by color -1. No, so it's not really about normalizing. Well, yeah, it's sort of. There are a bit more tone mapping operators. This one, oh, what the well, this is something interesting. Wait a second. Oh, no, it was correct. I wonder, it looks still a bit, because this should be between 0 and 1 here. Well, this is actually exaggerated, so that looks like crap. We can actually go and pick some nicer colors now. I have here some tone mapping. Yeah, so this was the thing I wanted to add. What's the name of this guy? Reinhardt. Oh, like the Overwatch guy. Nice. So let's go a bit here. What did I do with the colors? Ah, I remember this. First of all, let's make the background darker a bit. And that's in the clear screen thing. So yeah, it's sort of like normalization to go back to that point, but it doesn't linearly go into 0, 1. So the transform shouldn't be really linear. But anyway, let's see this. What is this? Oh, but 0.2 is quite... Ah, I need to recompile this. Crap. Oh my god. Okay. The black is okay. And these guys are semi-okay. Wait. Well, that's true. Feel a bit lazy about adding this, but yeah, we need to add HDR as well as. Whoa. What did I do here? I panic explicitly in shader RS. If I can't compile a shader. What's this for? This shouldn't actually be a panic. But before we go in and do HDR as well, we can live with this ugliness for now. And I think I know why they look so ugly. Besides the HDR thing is the fact that the colors here and the background are quite close together anyway, so. But yeah, HDR will help and make it look proper. So in that case, but I really plan something else for today, and that is adding the the spheres, because wait, let me show you what I want to do. We have the reload, and there used to be some spheres where these guys collided with and they bounced off of them, but on the C++ version of this. And now I have this collision disabled in the compute shader. Where is it? These are ugly names. I need to think of a better extension or something. Yeah, so this thing here, we need to make the mouse again, and they don't work now because the spheres were some buffers here which have offsets and the radius, and they have to be 20 because I don't really know. So at the time when I wrote this, there was no way to submit variable length arrays into the shaders. So without this being a constant here, I think there was no way to do something like this where you get sphere count as a uniform. So maybe things changed. Because when I first did this, we didn't even have... Wait, let me remove that for now, because it's kind of annoying me. Copy to texture, and we just output the... And come back to this. And do it properly, yeah, with HDR like in that. I'm not really a render guy, so... How do they... Maybe it's because of my buffers aren't properly set up. Well, I think... One other issue here is that the particle colors and this background color are way too close together, and that's also an issue. Yeah, let me check something first actually. Yeah, so they're too close together anyway to look good. And when we bring them and gamma correct them, then... Oh, what happened here? Then this happens. Wrong. Anyway, let's add the spheres and then we'll take a look at adding some nicer colors, because I remember why I'm a bit reluctant to change this now. Where are the vertex shader here? Where is it? I'm blind. Okay. So let's make them wow. Okay, now, yeah, I assume that those are kind of the values that they have. Oh, sorry. So in that case, can get back to it later. Oh. Leave it like that for now. And let's add here some of those spheres and collide with them. So for the spheres, as I said, we need to put these two: sphere radius, sphere offset. This means let's see what we have in the shader setup. This should be here in update. Let's set just one sphere for now. So that's a vector 3 array and a float vector. So this means I think I don't have wrappers for them, so is it float vector? Let me check. Ah, crap. 1. Oh, I have float vector. Oh, this is float. Never mind. I am blind, so I had this already. Because these get a count. I have 1 float vector and I need a 3 float vector. Okay, so these are here already. In that case, we just need to go hardcode some things here. So this should be fine, I think. Oh really? I thought I have seen 1 float vector. Content. This API is kinda shitty. Or maybe, yeah, this is fine. I'll just I'm having an internal fight with myself if this count should come after the array or never mind, useless. I'll just leave it like this. And now we need just the names from here. Nicer thing that we could do, but I'm not really worried about it, is copy this. So getting only once this uniform location, not each time we set it, but yeah, let's test this. Would be nice if they could just oh yeah. Nothing C++ here. Okay. Is it something here? I think it may be too small. What? 30. What? It worked. Okay, so whoa, something's happening around here. Am I not resetting properly some stuff? So one thing we could also work on is on the random generation of these guys' positions. Yeah, so most of them slide off. There's a case where these guys get stuck to it, but slowly move. Oh yeah, not too bad. Now we just need to make it proper. And by proper I mean we'll just add here, or don't like the fact that this object is starting to be a bit bloated. I'll just do a collider. Oh, it's an array of floats of 20 elements because I'll just hardcode yeah. We're not in C++. I don't even... But then I'll have to alias it. Let's leave it like this for now. I wonder if it works for this. It should work, I think. So here I can just do... Actually, I'll just do like this. But I do want debug for this. And here I think default is needed anyway. So y is always 0 and okay. sphere positions. So I think it's just like this. Y, let's put it at 0, and Z is the same. So we only have them on the ground. And now in the update, look how nice this is hard coded. I don't like this. Can I get a count from a slice? I wonder. Yeah, so we need to use this if we want to have vec3 and nice positions and have 20 elements instead of what we did now, but it's okay. Wait. Just check that the stream still works. We'll do it the ugly way. When that works, we'll improve. So we were in update. Hope this will not be an issue. So 20 sphere and 20 of these. It's kind of shitty now. Kinda. Oh, and this new should return actually. Ah, wish they would initialize to 0. Oh, okay. Easier than expected. What's even the plural of radius? Radii? Radii? Oh, I wonder if there is a floating point range. And now we don't need this default anymore, actually. So we need to implement debug for this. Let's leave it out for now. Okay. Oh, I know exactly what happened. What magic is this? So what do you see? This would be the biggest one. I think I exaggerated with the sizes. Cool. Wait, something actually really annoys me. So let's say if we hold shift we should move faster. So when we do the handle camera input thing here, uh, I can't tell actually what's nicer, this or this. Anyway, can leave it like this. And if let's put some acceleration in this. Oh, also, okay, wait, I got distracted. I'm like a fish. Okay. Yeah, I need to change this because started with double and then I changed to floats because the library wants the data wanted floats and so on. Yeah, but they hit the spheres. Look how nice. Well, thanks for the subscription, Bran Talk. I hope I didn't blow your guys' ears off with this sound. Or maybe only I hear it and my ears blew off. Anyway. So what I want to do actually, other than beautifying this a little bit, is We now have collision with these spheres, and let's crank it up a bit. We have what, 6 million now? Let's go for 10. I also need to see. I don't remember what this should be. But I think it looks okay. It moves pretty smooth here. I'm not sure how this is captured in the stream, but it doesn't look to drop frames or anything like that. I mean, because I'm encoding with the graphic, let's not put that much burden on it. Okay. So we did all these changes. We might as well push on Git. Do I need? The question is. Oh, I'll be right back. I'm sorry. There's somebody. Oh, never mind. So it looks pretty neat. I don't like the fact that they stick around to these spheres. But it's pretty fun to watch. And I hope that when I'm recording it won't have 1 frame per second, but anyway. Thing is, I'm also encoding with my video card and doing lots of things with it on this. So I will just go and clean this up a little bit. We don't need debug for those spheres. They worked from the beginning, so I don't really need to print them out. I would really need to redo this though before I push to Git. So in order to do this, well, it's quite easy. We can do a small improvement. I think vec3 should also exist in the yeah, this should be a vec4 actually, and actually this is so stupid. Okay. So let's fix these first. And then we'll do something really nasty, but you'll see. Because we need to translate from a vec3 array to a slice of f32, so that means we need to do a bit of trickery and okay. YZ, radius is fine. 20. I wonder if this works. Oh man, this would be but we're not in. And again, we're not. I'm still a Rust newbie, but I really like this language. It's super nice. Of course, nothing works now. What's wrong with radius? No field Z. Oh. And let's make it even nicer. Oh yeah, this. So he expected a slice here, but got an array. So from raw parts. Oh crap! Really? Thought I'd used it before, but I think I removed it. So you might wonder why I deposition. I think I remember, because I kept adding these things and then I forgot what I was doing and I forgot to make them nice. No fields. Oh no, this is a new thing. So now we should just have this error here. Yeah. One easy way to do it is let me see the documentation for that. Has a pointer and a length. Yeah. The shame. And actually, I wonder if I can just make this buffer and do it once instead of binding this over and over. Oh, because we can actually move them. Yeah, it's better too. So positions buffer. Sphere positions. Pointer. 20 of them. And then we just put them here. And I want this to be I think this is the correct way. Not sure about wait, what's the namespace for this guy? Nice. Really? Oh. Do I need to declare it like that? Wait a second. Wait, where is my... lost my thing. I need to okay, expected slice found reference. This should be already a slice now. What? Wait a second. Does this work actually? It doesn't change the... Wait, how did I solve it for? Does this mean this will work? Because I need to change this thing to be a... What is it? Yeah, because the type of this slice is the type of this guy, which was a pointer of vec3, but if I cast that as f32, then magic. Yay. Victory. So now our spheres are here and they kind of bounce off of stuff. I'm not sure if I should make the particles smaller or bigger. If I make them smaller, they will look even worse on stream probably than they do now. Anyway. Oh. One big thing I want to do with this, so now we're colliding with some distance fields, which are these spheres. They're described as sort of distance fields. So main nice thing that we could do is to take a mesh that's plain mesh coming out of a 3D program like 3D Max or whatever, and take that mesh and transform it into a distance field representation. In that way, we can collide against anything. Also, this collision needs to be fixed because it's kind of bad right now. I mean, it's pretty okay-ish, but I don't really like it. because they kind of stick to the, due to the way it's made, they stick to this, and it's not ideal. Anyway, cool. Cool. Oh, and another thing we could do, and this might be easier and worth doing before we do this, is put some, well, there are many things we can do. First of all, first thing that comes to mind is to put some textures on these tiny quads. That's one improvement. Then we can also think about how we can take a random mesh and make a distance field out of it. I didn't do this before, but I kind of have an idea. Basically, I think we could just use a sort of a grid of a 3D texture, basically 64 or 128 by 128 by 128. So this will be a grid, and we, for each triangle in that mesh, we test and set up the, actually for each cell of that grid we set up the distance field by basically rendering that mesh in the grid. But I have no idea how exactly that will work. In any case, this works now and we kind of cleaned it up. We might as well push something to Git. Oh yeah, by the way, this is on GitHub, so whatever, if anybody wants to take it, play with it, I don't mind. Okay, there's no more position and velocity. We moved shaders here, so should do more, but I forgot. What was it? Control R. We spawn spheres randomly at random. Okay, this is just beautification. Here's, so this is fine. Okay. When you press shift, camera moves faster. I've put more particles. Oh, by the way, if you take this, you'll need OpenGL 4.3 for it to work. Oh, let me fix that. So We did some sort of tone mapping, and the thing is, it kind of failed, so I'm not going to add this. This is the same. I just made this. The color is vertex color. It's probably just a space or something. Okay. And yeah, shaders don't crash anymore. Double check that we didn't screw up anything. Let me rerun this. Yeah, some of them. It's pretty okay. I wonder what positions are here. I can just spawn them there. Anyway, let me. It worked. Let me submit it. Git. And we push to master. Nice. I need to read a bit on this HDR thing now, so exposure tone mapping. Reinhardt. So the thing is, I use this and it look like crap, because most likely don't we need to adapt to these as well? Oh, actually it's correct. I just overexposed it maybe. Oh, this way we do it nicer. So they're here. This is yeah. And if I go here and pump up the color of these guys, large speed. I think this is, oh, more speed is white. This is white. What? Let's see how this goes. Oh. Okay. Honestly, I don't really get. I don't remember what this is. Okay, so it's kinda right. It's kinda right, but we need to do get this. But it might just be correct because this is interesting. Did I not place the color right? I wanted something really dark and not black. I think CG Matte also might have some back 3. Okay, and now it's a little bit better. Another thing that we can change this. Yeah, let me push this because it's okay now, and we also have the thing tone mapped properly and so on, I think. They're unchanged, why do you show me? That's it. Actually, yeah, I wanted to fix this. So we need to expose, we tone map it to put it back in the proper range, and then we have a gamma corrected color at the end of the day. Nice. Are these crosses? Anyway. And then we can add some more effects and stuff like that. Yeah. For now we'll set this to GitHub. Tone mapping here. Oh, what? I'm confused as to how this. Okay, buggy software. Okay. Or we can actually try this one. Look how nice this is now. It brightened up a lot. Which one was this? Anyway. I will take a little break before I think we can continue a little bit more, but yeah, break for now. Thanks. 5-10 minutes.